Assalamualaikum and good day everyone. My name is Mazliza Mohtar and I'm from Pusat Permata Pintar Negara, Universiti Kebangsaan Malaysia. Today, I would like to share with you my research entitled Gender Differences in Physics Achievement Among Malaysian Gifted Students. Here is the overview of the presentation. Human resources in science and technology are a valuable national asset. Thus, to produce more highly skilled human resources in the field of science and technology, the Malaysian Ministry of Education has launched a mission to ensure that the country's upper secondary student ratio will be 60 to 40, with 60% of students in the science stream and 40% in the arts stream. When the policy was introduced in 1967, it was intended to encourage more science students to go into professions related to STEM, such as engineering, healthcare, science education, information, and communications technology. However, it was discovered that the intended number of students pursuing science subjects is still far behind. The perception that science subjects are difficult is one of the primary factors attributed to the lower enrollment of students in the science stream. The poor achievement of students in science, particularly physics, has remained a serious concern for all, particularly those in the mainstream of science education. In order to stay competitive as a developed nation, it is crucial to build a pool of highly competent and STEM literate future workforce, not only to be technology users but also to have the skills and expertise to initiate or spark new innovations and technologies. Hence, there is an urgency to ensure the country has an adequate supply of talent pool in STEM. STEM education is derived from the acronyms for science, mathematics, engineering, and technology. In the context of our country, STEM refers to educational policies and school curricula to increase competitiveness in science and technology for students. This initiative has also been incorporated into the Malaysian Education Blueprint 2013 to 2025, which is aimed at ensuring the equipment of students with sufficient knowledge and skill in line with the ever-increasing demands of the contemporary industrial world. STEM education has become so important to ensure Malaysia can prosper in the future. As a developing country, we need professionals such as researchers, scientists, and engineers to motivate economic development. Through STEM education, students will learn to embrace, explore, and adapt to new technologies instead of being uncertain or fearful of them. Based on the report produced by the World Economic Forum, it can be seen that 90% of the top 10 emerging jobs in Malaysia are those related to STEM. If they don't get enough exposure, they will fall behind and difficult to compete in the future. Malaysia has targeted 60% of secondary school students to enroll in the science stream and enhance their knowledge and expertise in science and technology. However, until now, the percentage has not been achieved. In fact, it is more worrying as the trend of students choosing to major in STEM fields in school appears to be decreasing. According to data from the Malaysian Education Ministry, the percentage of secondary school students in STEM stream from 2017 to 2022 decreased from 45.2% to 40 from 94%. It is found that the decline of student enrollment in science also occurs worldwide, including in developed countries. Please, sorry. Physics is often perceived as a difficult course for students from secondary school to university levels. Based on statistics released by Ministry of Education, the number of SPM physics candidates is decreasing every year. The percentage of failed physics candidates increased from 0.8% in 2020 to 1% in 2022. This is due to factors such as the perception that physics is a difficult and boring subject, as well as a lack of understanding of the problem and poor mathematical skills. Remarkably, physics has been the most disliked discipline among other science disciplines such as chemistry and biology. Research indicates that ineffective pedagogical approaches result in poor physics performance among high school pupils. According to a study by Vilu and Khalid, teachers in schools have always commented that students' poorer physics achievement is caused by their negative attitude and lack of interest in the subject. The study revealed that positive attitudes toward a subject encourage students to work harder and achieve better results in that subject, whereas negative attitudes toward a subject make learning more challenging. Godwin and Okoronka and Mazlan and Nick Abdullah also discovered a significant correlation between student attitude and their academic performance in physics. Understanding gender differences in physics achievement is important for a number of reasons. First of all, it makes it possible to create instructional strategies that are suitable for improving the academic achievement of both male and female students. Secondly, analyzing how students' attitude towards science and physics differ depending on their gender can help identify the causative force of the gender gap in STEM. Understanding how gendered identities are constructed in physics learning and practice can challenge prevailing notions of who can study physics and what constitutes physics competence, thereby fostering a more inclusive and equitable field. Generally, male students are found to be more interested in physical sciences, whereas female students are more interested in the biological and environmental sciences. Therefore, this study aimed to investigate the effects of gender on students' physics academic achievement among the Level 1 students of College Permata Pintar Negara UKM Malaysia. The findings of this study are expected to be able to assist physics instructors in coming up with suitable strategies to improve or further enhance the students' performance. Furthermore, more effective academic planning based on students' preferred methods of learning can be carried out. This study was conducted on a sample of 88 Level 1 students of College Permata Pintar Negara, Universiti Kebangsaan Malaysia, aged 15 to 16. The demographic data of the student is shown in Table 1. These students were divided into 5 classes, and all classes were taught with a physics syllabus for 2 hours per week. There are 2 types of assessment in every exams that contribute 100% of the marks. Summative assessment contributes 60% of the examination score, and 40% comes from formative assessments. Table 2 shows Table 2 summarizes the construct of each assessment. The results of every student's physics exams were collected. The examination results indicate the student's understanding or performance level. Data analysis has been conducted using IBM Statistical Packages for Social Science SPSS V23. The t-test was used to determine the mean differences and relationship between gender and physics academic performance. Table 3 shows the physics academic performance for examination 1 between male and female students. As seen in Table 3, the mean score for male students is 90.66 and for female students is 90.41. The mean score of male students is higher than the mean score of female students. It was found that the t-value for the comparison of male and female student score was 0.180 and the significant value was 0.982. Therefore, there are no significant differences in physics academic achievement based on gender since the p-value are greater than 0.05 for examination 1. indicated in Table 4, the mean score for male and female students respectively is 79.28 and 78.24. These results show that male students' mean score were higher than female students' mean score in the second examinations. The t-value was found to be 0.061 with a significant value of 0.566. The p-value for examination 2 are greater than 0.05, indicating that there is no gender-based differences in academic achievement in physics. The results were illustrated in a chart as shown in Figure 1. As seen in Figure 1, the mean score for each exam differ for male and female students. Male students score higher on average than female students on all physics examinations. Nonetheless, there is not much of a difference in the mean score of male and female students. A similar result was also demonstrated in a study conducted by Aina and Akin today. They found the physics academic performance of male students was better than that of female students. Research done by Tai and Sadler discovered that male students score moderately higher on physics, chemistry, and computer science than female students. Many studies also reveal that male students have greater achievement in STEM subjects than female students. However, another study by L1 and R1 found contradictory results that female students perform better in physics than male students. This research revealed that there were no significant difference existed in the physics achievement based on gender among the Malaysian gifted students. Hence, it is shown that there was no relationship between the physics achievement and gender. The result indicate that the students have same level of understanding in physics. Based on previous studies and researcher experience, student physics achievement is influenced by their attitude and interest in the subject. When compared to female students, the majority of male students had issues with commitment and attitude. However, they consistently outperform female students academically. Therefore, it is suggested to find out students' attitude and perceptions towards the teaching and learning of physics based on their gender for the next study. With that, I thank you.